Okay, today we're going to learn how to use the ideal gas law to solve for density and molar mass. So to do that, we need to first think about what are density, molar mass, and the ideal gas law. So we've learned previously that density is mass divided by volume. And we've learned about molar mass in that it is the mass divided by the moles. And then we just recently learned about the ideal gas law, which is PV, pressure times volume, equals moles times the gas constant times temperature. Right. So we want to use all of these things to help us figure out a way to get density and molar mass given information like pressure and temperature. So in all of the problems, you'll be given density, and of course, the ideal gas law, or molar mass and ideal gas law. So in order to do that, we got to think about what they have in common, right? So both of these have mass in common, right? And then density has volume in common with the ideal gas law, and molar mass has moles in common with the ideal gas law. So let's look at first finding density. So we know that density is mass over volume. So what we need to do is think about how can we use these two equations to solve for mass and volume. And then we would need to divide them. So let's look at this one first. So how do we use molar mass to find mass? So our molar mass is equal to mass divided by moles. So if I wanted to solve this for mass, we're just going to use an M for mass. We're going to use an N for moles because that's the same letter we use in the ideal gas law. And then we're going to use a little m for mass. So we got a big M and a little m. Alright, so our molar mass is our mass over moles. So to solve for mass, we'd multiply both sides by moles. They'd cancel here, and then we would get that mass is equal to the molar mass times the number of moles. Right. Now if we use the ideal gas law, because now we have a value that will equal to mass in our density, we use ideal gas law to get us to volume. So we have PV equals nRT. So I want to solve this for volume. So to do that, I would divide by pressure. My pressures here would cancel, and I would get that volume equals nRT divided by P. Now, if we plug these two things here, mass and volume, into density, we would get that density, and then instead of using mass, we're going to use molar mass times moles, divided by, and again, instead of using volume, we're going to use what volume is equal to, nRT over P. Well, now we have this ugly complex fraction, so we need to simplify it. So if you recall from math class, to do that, you leave the top the same, you change division to multiplication, and then you multiply by the reciprocal, right? So what we're going to do is multiply P over nRT. So we just made that the reciprocal, right? And now we can simplify. We have an n on the top and an n on the bottom, so they would cancel. Nothing else would cancel, and then we'll just rewrite this neater, and so we get MP over RT. So now we can use this to help us solve for the density. So let's look at a quick problem. So if our problem was, what is the density of carbon dioxide at STP? So we would have to plug in what we know to our equation, right? So we know that density is equal to our molar mass. So what's the molar mass of carbon dioxide? Right, we add a mass of 1 carbon plus 2 oxygens, and that gives us 44.01 grams per mole. Then we have to multiply that times our pressure. We're at STP, so that's standard temperature and pressure. It does not matter what unit of pressure you use. Use your favorite one. Doesn't matter. I'm going to use ATM, so I think that one's easiest. So we get 1 ATM over R. Now remember, your R has to match your unit of pressure. Again, that's found in your reference packet, your gas constant. And for ATM, that's 0.0821. And then we'll multiply by our temperature, and since it was STP, that's standard temperature, remember it has to be in Kelvin, so that's 273. So then we multiply and we divide, and we get 1.96. Now the units here are going to be grams per liter, because remember, for your ideal gas law, because of this gas constant, it uses liters. Remember, our ideal gas law must always use liters for volume. So that's the unit of the volume that we end up getting in our density. So grams per liter. Alright, so let's look at finding the molar mass then. So we're going to use the same process as we used up here, right? Since for molar mass we need a mass, we can solve density for mass, and then we need moles, so we can use the ideal gas law, and we can solve the ideal gas law for moles. Alright, so to solve density for mass, we would say density equals mass over volume, right? To solve for the mass, we multiply volume on both sides, and so we would get that mass is equal to density times volume, right? So then we need also for molar mass, we need moles, so we need to use ideal gas law to get us to moles. So we have PV equals nRT. Now to solve for moles, right, I need to get RT over here. So just divide both sides by RT. And that will give us that moles are equal to PV divided by RT. So now we can plug into our equation for molar mass, which is mass divided by moles. So our molar mass is mass divided by mole. So we just solved density for mass, so we'll replace that. That's density times volume is mass. Then we'll divide by moles. Well, we just rearrange ideal gas law to find moles, so that's going to be PV over RT. Again, we have this complex fraction we need to simplify. So we're going to just multiply by the reciprocal, right? And then we're going to cancel. So we have a volume on the top and a volume on the bottom, so those cancel out. So we simplify that, we get dRT over P. Now, you don't need to know how to derive these equations, but you do need to know the equations. And I think this one is the easiest one to remember, because if you ever gone camping and you haven't had a bathroom, sometimes you have to go to the bathroom in the woods, right? And so it's always a good idea to cover your pee with dirt, right? So it helps you to remember molar mass, right? dRT kind of looks like dirt, right, over P. So cover your P with dirt. The way you can remember that. Okay, so let's look at a problem. In this one, we're going to find the molar mass. So what is the molar mass of a gas that has a density of 1.20 grams per liter at 1.5 atm and 22 degrees Celsius. Okay. Alright, so let's look at this problem. So our molar mass, we just found that we can find that by doing our density, which was 1.20, times R. Now remember, R has to match our pressure unit, which in this case is ATM, so that's going to again be 0.0821, times our temperature, which has to be in Kelvin. So remember, we have to add 273 to this, and we get 295 Kelvin, over our pressure, which is 1.50 atm. Right? And when we multiply and divide, we get 19.4 grams per mole. Again, we found molar mass, and so the unit is grams per mole. Alright, so we'll be using these equations in class tomorrow. Okay. You want to make sure that you know these two formulas. So I would star them and start trying to commit them to memory. Again, you can just do the one here and or that one if that you prefer that one, and then you can always derive one from the other because they both have density and molar mass in them. And that's all for today.